Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 8-5, on the angles of elevation and depression. And these are the only two vocabulary words that we're going to be covering today. So let's go ahead and get started and make sure you put these in your notes. All right, the angle of elevation is the angle between a horizontal line from an observer and the line of sight to an object that is above the horizontal line. So here's the horizontal line here, and there's the line of sight here in blue. And this angle right here, from here to here, is the angle of elevation. And here's another example here. This person's standing on the ground, and so they have the horizontal line right here where their eyes are, and then their line of sight up to the very top of the Eiffel Tower, and this angle right here is the angle of elevation. And now the angle of depression goes the other direction. So once again, you have to start from a horizontal line, and then they're going to be looking down at something. So their line of sight is going to go down, and the angle of depression is between the horizontal line and their line of sight. So now here's that same example again, but this time from the gentleman standing on top of the Eiffel Tower. Here's the line from his eyes, and then here's his line of sight down here, and this is the angle of depression. It is important to remember that angles of depression and angles of elevation always go from a horizontal line. Often, in order to use your angles of elevation and angles of depression, you need to remember your trigonometry functions, your sine, cosine, and tangent. And remember, in order to do that, you need to remember your SOHCAHTOAs. Your sine equals your opposite over your hypotenuse, so. Your cosine equals your adjacent over your hypotenuse, CA, and your tangent equals your opposite over your adjacent, TOA, SOHCAHTOA. Now let's go ahead and do some of the problems from your assignment. They want to know which is the angle of depression from the birds to the ship. So we have to start up here at the birds and go down to the ship. And remember, it always comes from a horizontal line, so this angle of depression would be angle 1. Our angle of elevation from the ship to the birds, remember it has to go from a horizontal line up to the birds, so that would be angle 2. This one asks the angle of depression from the ship to the submarine. So from the ship to the submarine, remember we need a horizontal line and then our line of sight. Our angle of depression here would be 3. And last but not least, from the submarine up to the ship, we need our horizontal line and then our line of sight up. Our angle of elevation here would be angle 4. All right. The next one wants us to use the diagram below to find the height of the flagpole to the nearest foot. The person's eye level is 5 feet from the ground. So it is important to remember that from here to here is already 5 feet. And then we can use our trigonometry since we know one angle and one side of this right triangle that gets created here between the person's line of sight and the top of the flagpole. So this angle of elevation is 35 degrees. We know the person is standing 30 feet away from the flagpole, so we can use our trigonometry to figure out the height of the flagpole from here to here. From our angle, that would be across the entire triangle, which would be opposite. And since neither one of our sides here are the hypotenuse, we're going to use the opposite over the adjacent, which will be the tangent. So the tangent of the angle of elevation here, the 35, will equal the opposite, in this case x, over the adjacent of 30. And then we'll solve this for x using algebra. And what we get is that the opposite side of the triangle here is approximately 21 feet. But we do need to remember that it's asking us the height of the entire flagpole, which is 21 feet plus 5 feet. So our answer would be approximately 26 feet high. And then our last one says, Miguel looks out from the crown of the Statue of Liberty, approximately 250 feet above the ground. He sights a ship coming into New York Harbor and measures the angle of depression as 18 degrees. Find the distance from the base of the statue to the ship to the nearest foot. So here is a very poorly drawn example. So Miguel is 250 feet up, so he's standing over here. and he sees the angle of depression as 18 degrees, just like that. And it wants to know how far away the ship is from the base of the statue to the nearest foot. So essentially we have this triangle with an 18-degree angle of depression. Opposite from that is 250 feet. And we are looking to see how far away the ship is from the statue. So that's the adjacent side here. So we're going to want to use our tangent again. So I've drawn this on this next page here, and this is our problem. We are definitely not using the hypotenuse across from the right angle, and instead we're going to start from this 18 and we're going to go across the opposite to 250 next to the adjacent here, which is going to be x. So the tangent of 18 will equal 250 over x, and then we'll solve this with algebra. And what you get is that x is approximately 769.4, which means that he is around 769 feet away from the ship. Good luck, everybody. Hope you guys all do great.